finish up what we were doing. Now, now, the way I'm going to do this is that if you're not here for the final, you will get a grade based upon your homework only. But it would be impossible to get an A if you don't show up for the final. It'll be a grade either a C or a B if you don't show up for the final, depending on how good your homework is. If you want an A, you have to show up for the final. But there are no other exams. Either you're there at the 18th, or you just get the grade based upon the homework. Good. Now, when I say a C or a B, I mean a C minus, C plus, a B minus, a B plus. For that whole range.
Yeah, I got it.
That's 6, correct? Yeah. Yeah. Does that take care of your problem? Yeah. I didn't have it. You told me that you had to go to... Oh, not you. I had
Oh. Be good for your shaving set.
I just saw the order shaving coming circle.
You got shave. Their stuff is expensive.
You're from Gettysburg? Nice.
Oh, wait, you use Facebook?
Of course.
I was like, wait, what? They have some good stuff now.
Sweet.
Awesome.
We should make a tennis court.
Like the way you said sometimes it's torture to the government. We should.
Now you can your life beyond
Yep.
Yep.
It's pretty much the same BS thing.
Let's say if you're in the jungle, use your sputum. Yeah, sure.
That's what I use.
More than anything.
Thank you. It took forever to grow, and I shaved it up to super itchy.
Oh, super itchy?
Yeah, it's miserable.
I feel like all you do is report things.
Yeah, I used to, yeah.
But that's how you know it's disinfected.
It burns.
It doesn't burn.
Well, another thing you can do is you have salt around it.
Now it's like this whole different world, being here,
Honey, no
paying
bacteria
bills and
grows
stuff.
honey.
Is that right?
Yeah.
Oh, yeah.
So if you have honey, anytime you have a actually like a cup of gas,
You know what?
put honey
You know
in
what?
it.
Yeah.
Bacteria grows in money. They're scared of the bee.
Now I'm writing you messages that I can't say too loud. Tell
Right
Poland.
here, not equal. Down here. Also, I forgot to put the name of the country. Where? What are you doing?
It's large and
Not
it's
equal at the bottom. What do I say? Talking about the X minus
How many decimals?
It's literally just like
Saving and your net export.
you get
8.8.
grade out of 100, so whatever you have lost off. That's how much percent you've lost.
When they have to do it. I guess because like you just know what to refer to.
There's no like,
If I'm not,
gives us so much time.
you go in, fine. I'm talking about 2 hours. I didn't get any of that.
There's no speculation, like if he.
Sounds chill.
But he knew.
Now you get more points out of it.
Yeah. Last week I didn't.
To include two
That's the way,
components,
okay, I see what you're saying.
X1 and X2. And the same type of assumptions will be held. The covariance between X1 and X2 equals 0. I believe. It's called, when it's not, it's called collinearity. And that's the problem. And the covariance between epsilon I and epsilon j also has to be set. When that's not true, we call that serial correlation. And that,
You have to do a master, so you have to.
now, if you have those two problems, then none of these regression results make any sense. Now, we'll go through this the same way we did the other one.
Just walk in.
The basic idea is to reduce the squared error, minimize the squared error. And we want to find their coefficients B0, B1, and B2, which will give us the linear equation which will minimize that squared error. Now, before we actually get into this, think about what we're looking at. Because now we're in 3 dimensions. So you have X1 going this way, X2 going this way, and Y going this way. And the linear equation in 3 dimensions.
That's what we were doing today.
Yeah. Sorry? What are you talking about? Huh? The linear equation in 2 dimensions is a sheet. Like, imagine a sheet of glass coming out of the corner like this. That would be a linear equation in 3 dimensions. A linear equation in 2 dimensions is just a straight line. Right? What is this like in 4 dimensions? What would a linear equation in 4 dimensions?
You would have the line coming out of the origin, 45 degrees.
You can't see it.
You can't see it.
You can't see beyond 3 dimensions.
But is that a
Unless you
possibility?
take drugs or something like that. We only can see in 3 dimensions. After that, these things become warped in hyperspace. But we can calculate in 4 dimensions. We can calculate in 5 dimensions and so on. We just can't see it. But in 3 dimensions, you can think of this like a big sheet of glass coming out. Coming out something like this or like that. Just going through space. Good. Now we're dealing with linear equations always.
You're on channel.
So to minimize this, we have to do what we did before. We have to minimize B first with respect to B0, then with respect to B1, and then with respect to B2. Now, when we do it with respect to B0, we end up with this equation over here. When we set it equal to 0, we have y bar is equal to B0 plus B1 plus x1 bar plus B2 x2 bar. And then when we do it with B1, we end up with this equation over here. The sum of x1 times y, the B0 the sum of x1, B1 sum of x1 squared, and B2 sum of x1 times x2. And if we do it with respect to B2, we end up with B0 times x2, and B1 times x1 times x2, and B2 times x2. So now we can summarize the three conditions for minimizing C. Number one, y bar has to equal B0 plus B1 x1 plus B2 x2. Bar is the averages. The second one is the sum of x1 times y1 B0 times x1. X1 squared plus B2 x1 x2. These three. So we solve these three equations with three unknowns. Right? And we'll solve it using matrices. From the three equations, we pull out B0, B1, B2, and put them in the vector. And we end up with this matrix of coefficients. The coefficient of B0 up here is 1. The coefficient of x1 bar is B1 of x1 bar. And the coefficient of B2 is x2 bar. What's your name?
I have it.
Yes.
Your problem's taken care of, all right?
What was that?
Your problem's taken care of. You got my email?
Yeah,
right?
I can get to that first.
I didn't want to leave you guys in.
Mine is in, just go ahead.
Now,
I know, they're fucking hitting each other.
likewise for the second row, the coefficient of B0 is sum of x1, coefficient of B1 is sum of x1 squared, and so on, right? And B3, for the third row, we get these coefficients over here. So we have that matrix. And this vector, and we get that. This is the right-hand side. Over here, y bar, this one. Now we're going to solve that using matrices. The solution for B0, B1, and B2 that will equal this matrix here. Inverse. In other words, we have to take the inverse of this, move it on the other side, and then multiply that by this using the matrix multiplication. And that will solve the B0, B1, B2, a simple matrix, inverse, and a multiplication. Now remember what we did last week. We only had one variable as an explanatory variable, the last week. So all we had was B0, B1, and then we had this part of the matrix. 1 x bar, there's only one there, and we had the sum of x squared. Times y bar, sum x. This is what we did last week. This week we extended it to this. Now I want to find out what's really in a student's class. I'm going to ask you to extend this to the next dimension, which is 4 dimensions. 3 explanatory variables.
I'm not gonna say anything anymore.
Mohammed, you almost done?
He's already got it.
Huh?
You almost done?
Maybe you should email those notes to everybody.
You mean the test?
All right? And each one of these is an index of I. Now I'll give you a hint. You don't have to do any differentiation to do that. All you have to do is see the pattern in these two, and you can write on the next one. So who thinks they can tackle that? You don't have to do any differentiation. All you have to do is look at this and see the pattern in this, and you should write the next one. And you can write the next one, and so on.
You don't see the pen?
You got it figured out?
Think so.
Huh? All right, good. We put it on the screen here. Come on. Put it on the board.
Might be wrong.
No, if it's wrong, I'll show you. It's very easy. All you have to do is look at that
Come
pattern.
on, let's go.
Yeah, get up there.
Just go.
Impress us. We need more.
Tell them your name's
Always
William D. Hey, new Facebook friends. My 64th picture has, I'm wearing a tie. It'd be really nice if you comment.
Right in the middle.
Not now. At your leisure, yeah.
Yeah.
But it's pretty
Three
high
variables,
for
I'll
a
do.
1, 2,
3
3,
explanatory variables.
x1.
If I'm wearing a tie in my 64th picture, I'm super fabulous because I just picked a number.
x1, x2, x3.
All right.
It's not a tie, it's a fly, it's water.
Thank God.
Do the wrong place, in the wrong time.
Pretty boss,
Didn't erase the
Ferrero. Oh, I thought.
Yeah. x1,
That work?
I think
No, I'm talking about the new.
there's a mouse.
sigma x1.
You got the first row right. Now start with the second row. No, you don't start there.
Make us proud, bro.
No,
We start right under the one. So there, yeah.
okay, sigma x1, yeah. x1 square. x1, 1. x1, 1, 2.
No. Are you ready? And Seraphin's not here yet.
He'll be most likely in later.
Yeah.
Where is it?
He had to drop his wife off somewhere.
No. Yeah, sorry, that's right. That's-
This?
No, yeah.
It's
I'll
one,
look at
two.
that.
It's one,
No.
one, two.
No. So you got x1 times x1 is x1 squared, x1 times x2.
I know
What's the
if I
next
complain
x1
to
times
that
what?
on Facebook, it was slow on his computers.
Yeah. Give me your
Good talk.
What's that?
Down there.
Another
one? No, we can get it this
slow on his computer.
That row is yeah.
This road's wrong.
Part of it.
This one.
Yeah, right. In fact, the second one is wrong too. No, not that, the second one, that one.
That was free. Just a little taste. You get for $6.
I charge $8.25.
You're a lot cooler than
You're in the hole.
That's too quick, okay, that's nice.
That's not true, you're like 1,000.
Been in a lot of places, seen a lot of faces off the wall.
No. Use the eraser.
So math guys, they're not
No.
You should go there.
Good. Now you got one more to go.
To the right.
Now you get one more wrong. If you got B3.
What, you want a mouse?
There you go, one over there.
Oh, this one.
Right, actually,
Storage and mouse.
No.
So what?
I'll give you a hint. If you look on the top column, look at the subscript. What's on that?
Not
on the top of the column?
by itself.
one.
One.
Yeah. That's why we're doing it as a matrix. Because
Now you go to the left and look at the subscript.
you have to solve each individual.
No. What's the subscript by the left?
The only reason I know what that means is because I know that you
Right.
use that and multiply by that. To solve it. But
Now you look
the
up.
numbers themselves don't. The only reason they have any meaning is when they're.
What is that?
Look to the left.
So you, this is that one.
Yeah, that's right. And what's the left? No, there is no extra, right? Yeah, but make it clear.
So let's say you want, for example,
No, erase one.
Let's see your version one.
X is equal.
Right? Let's say
That, now put the bracket.
Just a parameter, right? So the equation is
Yeah, it's reversed. And then you gotta multiply it by,
Yeah.
you can
There's no way
right
to
hand
get
side.
that proper formula mixed up, right? So then you have to do this. You want to derive the regression function.
Okay.
You have to do it.
Yeah.
So that's really all it is.
So you just use like this.
No, They have to do the whole, it's all part of the breaks.
That's why I want. So,
That's why, that's why.
Taking all the breaks off.
And the top
that's why.
No, I just wish I would have taken the time to learn about it.
X1 is X, the sum of X1 times Y.
So I really didn't start to.
Good. Do you see the pattern now?
Okay.
If you wanted to write another one,
Now it's.
you just follow this pattern.
So it's just study math.
I was looking at it this way.
You're almost there. You're not quite. You want to get another one. It is B0, B1, B2, B3, B4. Is equal to. The first row would be like this, all X bars.
That's right.
One,
It is. It's
X1
bonus.
bar,
It's gonna
X2
give you
bar,
5 points for that.
X3 bar, X4 bar. This side, Y bar.
The first one was what? Was it very quantitative like this? Yes. With Excel application.
Alright. That's the second row. We start with the X1, so the sum of X1, sum of
He uses
X1
technique for that.
times X1,
He doesn't use it.
squared, the sum of X1 times X2, sum of X1 times X3, the sum of X1 times X4.
Usually that.
Go to the third one. With the sum of X2, the sum of X1 times X2, the sum of X2 squared, the sum of X2, X3, the sum of X2, X4. Now we go to the next one. 3. The sum of X3, the sum of X1, X3, the sum of X2, X3, the sum of X3 squared, and the sum of X3, X4. We get the sum of X4, the sum of X1, X4, the sum of X2, X4, the sum of X3, X4, and the sum of X4 squared. No, no permutation. No, nothing to do with permutation. This is the sum of X1Y, the sum of X2Y, the sum of X3Y, the sum of X4Y. So you can, if you were, say, and this is English. Now why am I showing you this? Because it's all programmed in Excel, right? I show it to you because suppose you were working in a developing country. Suppose they sent you to Somalia, someplace like that. You meet some really bright economists in Somalia. They have PhDs from the London School of Economics and from all over the world. But they can't do a regression. Why can't they? If they don't have computers. Right? Or if they do have a computer, they don't have software. So when you go to developing countries, you have to be prepared to do that kind of thing. You've got to be able to start from scratch. As an economist in the UN, I was sent to developing countries all over Asia, Latin America, and Africa. Never had software like they have in the United States. They're always behind, but you have to be able to put that together. Sometimes you won't have any computer at all. So what do you do?
Manual.
Manually. And how do you do it manually in a developing country?
Paper and just calculator.
You get a secretary,
Oh, secretary. Okay.
and you lay it out like a spreadsheet in Excel, and you have the secretary do all the arithmetic.
Or you outsource it.
Columns, you put a column where you
Yeah,
add
those in
with
India.
X1, X2, and X3.